So today what we're going to do is we're going to look at something called exponential decay. We've already talked about exponential growth. We had talked about, like a rabbit population or dog population or a cat population or even people population, where we can start off with 2 people and then they have 4 kids, and then each of those 4 kids have a family, and how all of a sudden you can have a house full of people. Exponential decay is very similar to growth. However, rather than getting bigger, we get smaller. And so let's take a look at it in this perspective. Where do you think we'd see growth and decay? What do you think the difference is? Okay, of course, in growth, okay, number gets bigger. Okay, my graph looks like this. Where do we see that? We see that in population. Of course, that is with human beings, cats, dogs, mice, rabbits, those types of things. When we look at decay, right, number gets smaller rather than larger. The graph looks more like this, where it starts off very large and all of a sudden takes a dive. And where can we see this? Well, we can see this in population also. Where this population would be affected is more with like a death rate. Let's say smallpox, polio, measles, mumps, rubella, and then we as a society start looking at cures and inoculations and those types of things, because we have all these people and all of a sudden they're dying. Why are they dying and what do we need to do because of that? So here are some examples of what can happen. Another thing that we can look at is depreciation of cars or the values of cars. I have a $10,000 car, brand new car, $10,000, drive it off the lot, and all of a sudden it's worth like half. So that's an example of a decay. It gets less in value. All right, so you're going to notice with decay as opposed to growth, you're going to notice that the growth factor now is like a decay factor. And you're going to notice that this number right here is no longer bigger than 1. It's actually smaller than 1. All right. But how we handle these is very similar to what we did with growth. So the first thing we're going to do is we're going to make a table. So I'm going to go x and y equals 1/3 to the x power. We're going to have a y. All right. And then we're also going to make a table with the other function. And you'll notice again, it is very similar to what we've had before. The only difference is the numbers, rather than getting bigger, they're going to be getting smaller. So what I'm going to do in this first one, again, I'm going to pick -1. So y equals, 1/3 to the -1 power. Notice I have parentheses around the 1/3, and I do because it is a fraction. And then remember that that -1 ends up flipping my fraction, so I end up with 3. Then I'm going to plug in a 0. Anything to the 0 power, remember, is 1. And I put in a +1. I get 1/3. And you're going to notice that my values got smaller, right? Let's go to the next graph or the table. I'm going to put in -1. Now remember, this is a stepped problem, so make sure that you show your work when you do these. Every step counts, and I want to make sure that you show it on a test. I'm going to put in 0. And you'll notice that this also got smaller. All right, so I go ahead and I set up my graph or my table. I do the work on the table, and then I come over here and I need to make the graph. Right, so now what I'm going to do is I'm going to take those values and I'm going to go ahead and I'm going to graph these two on the same graph. And so if I took a look at the first one, I had -1, 3. I had 0, 1, and I had 1 and 1/3. Okay, and then you'll notice, like with growth, I'm going to get closer and closer to the x-axis, but I'm never going to cross that x-axis. And you'll notice that it kind of goes the opposite direction as the growth, right? And then what I'm going to do is I'm going to take those other values. I had -1, 6, 0, 2, and then 1 and 2/3. Notice that these graphs have that curve to them like growth, but rather than going up from left to right, I go down from left to right. Notice that they do not cross. Also notice that they never cross the x-axis, and that's really, really important when you draw these. Now, I need to go back, and it asks me to compare the graph, okay? It also asks me to identify the domain and range. And we've kind of already done this before with the growth. So if I talk about the domain, very similar to the growth, I got to choose the values for them. So it's going to be all real numbers with the range. Okay, you're also going to notice that I could have decimals, I could have fractions, but you're also going to notice that in this particular problem, they are all positives. Look at all my y values here. They are all positive numbers, right? So in this example, it's going to be all real, or I should say all positive, real numbers. Okay, so I've got the domain and range down. Now what I need to do is I need to compare the graphs, right? So what's the difference? The y equals 2 times 1/3 to the x is twice as steep as y equals 1/3 to the x. Okay. And you'll also want to make sure that you check the back of your book. Remember, with growth, it was vertical growth, vertical shrink, those types of things. So you'll want to make sure to check your books to see, you know, what they're kind of talking about as you do those. Right? Let's move on. Tell whether the graph represents an exponential growth or decay, and then write a rule for the function. So what we're going to do is we're going to look at this, right? First of all, if I go from left to right, am I moving going up or am I going down, right? You notice that I'm moving in an upward. So this is going to be exponential growth. Right, so it's an exponential growth. Then when you do these, what we're going to do is we're going to look at where it crosses the y-axis, and we're also going to take a look at a dot where it's easy to read the ordered pairs. All right, this one, for instance, is 0, 4, and this one is 1, 10. So what we're going to do on this, we're going to take a look at y equals ab to the x. And we've kind of already done this before. What I'm going to do is, remember, my a from before was my y-intercept. And you're going to notice that that is also the value of that 4 there. So I'm going to go y equals 4b to the x, right? And then what I'm going to do is I'm going to take the ordered pair that I have right here, and I'm going to plug it in for my x and y, because I don't know what my b is. So my y I said was 10, and my x was 1, right? So if I want to get this b by itself, I'm going to divide by 4 on each side. So this ends up being 2 1/4 as my b. Now you're going to notice that that really makes sense because it's a growth. So y equals, you're going to bring that 4 down, okay? You're going to take 2 1/4 as my b, and that's going to be to the x power, right? If you wanted to, you could also write it as 4 times 10/4 to the x power. I just happen to write it as a mixed number. Or you could even write it as 5/2, right? All right, let's go to the next one. This is the same type of example. The only thing is rather than it going up from left to right, it's moving down. So this is an exponential decay, right? And I'm going to highlight the y-intercept. And of course, this is 0, 5. And my ordered pair right here is 1, 1. So again, I have y equals a b to the x, okay? My y-intercept is my 5, so of course that's my a, and this is my x comma y that I'm going to plug in my equation. So I get 1 equals, my a is 5 for my y-intercept. I don't know what my b is, but my x is 1. So now to get b by itself, because that's what I'm trying to find, I'm going to divide by 5. And my b ends up being 1/5, which makes sense because remember my decay factor needed to be less than 1. And so to come up with this equation now again, I'm going to go y equals a b to the x, y equals a, which was my 5, b, which is 1/5, and that needs to be in parentheses because it's a fraction, and it's to the x power. Okay, and that is my equation for decay. All right, so that is it for today. What you're going to be doing is you're going to be picking your y-intercept and another point, and most of the time they make it a really dark dot on your graph. You're also going to be graphing some decays, and then you're going to be comparing. Again, make sure that you check your book to make sure that the answers are correct as you go.